Okay, this is going to be our third lesson of our unit, and today we're going to need to spend some time talking about some vocabulary. So, on the screen right now, you are probably seeing a bunch of vocabulary. Our learning target is identifying bases, faces, edges, and vertices. So, we're going to start with talking about faces of solid. On the side of the screen, you see two cubes. One of them is actually a solid, the other one is a representation of a solid, but we can actually see through it. So we can see all of these pieces or things that make up solids. We're going to start by talking about faces. A face of a solid is a flat surface on the solid figure. So real quick, I'm just going to go through and kind of highlight those on the solids. And then we will actually be counting the number of faces. Okay. On this solid, this is a face, this is a face, and this is a face. Now you might be thinking, there's only three. That seems kind of weird. But based off what we know about cubes or about solids, is that there is an opposite face that is the same as this face here, and one here in the back, and then also one on the bottom that is the same shape, a square, as the top face. Okay, so we have a total of 6 faces. Okay, the same thing here. This front part is a face. There is an opposite one behind it, kind of back here. I know it's a little bit difficult to see. One here, so 3, 4, and then 5 for the top, 6 for the bottom. Okay, so a cube has 6 identical faces that are all squares. I'm going to erase that and we're going to move on to talking about bases. Now, you are not going to be finding the number of bases. Mostly what we're going to look for is the shape of the base. That's one of the things that we use a lot to name solids or identify solids. So this definition is a little bit tricky to talk about or to explain. And as we get more experience with these solids, I think it's something that your understanding develops as we go. Okay. The base, the definition I have here is a special face of a solid. Now, most of the time, the base will be the shape at the bottom of the solid. Okay, but this changes a little bit when we talk about certain prisms or if they're flipped in certain ways. So for a cube, the shape on the bottom is going to be the shape of the base. So we know that that is square. Okay. Okay, I'm going to erase that. And we're actually going to use this yellow marker again for talking about edges. Okay. Edges, or an edge, is a line segment where two of the faces meet or come together. So on this solid right here, this face and this face meet to form this edge. Okay. Now, if we go through and do that for the entirety of the shape, we're not going to be able to see them all on this first solid. But let's try this out. So we have one here, one edge here, one edge here, and one edge here. So that is a total of 1, 2, 3, 4 edges. I know that when I have these square faces coming off of another square, I'm going to have 1, 2, 3, and then one here I cannot see for another 4 for where my middle faces are meeting. And then at the bottom, we also can only see 1, 2, but we know in the back there's 3, 4 as well. So this gives us a total of 12 edges. And they're a little bit easier to see on this solid that we can see through. So I'm going to try and do that on here. Let's start with the top again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Erase all that, and then next we're going to start talking about vertices, which are plural, vertex meaning one. Erase all this, takes a little bit of time. Okay, and we're going to use, let's use black to talk about vertices or vertex. So a vertice is a point or a vertex is a point where two or more edges come together. Okay, so I'm going to highlight on this red cube where three or more edges meet. Okay, so those are three edges, and they are meeting right here at that point, and that is a vertex. If you have more than one, they are called vertices. So 1, 2, 3, 4 at the top. In the middle part of this cube where two of these faces are meeting, like right here, this is not a vertex. That is just an edge. So now we're going to go down and count the ones at the bottom, and we can see 1, 2, 3, but we know there's also one back there we can't see. So we have a total of 8 vertices. I'm going to use a different color to show that on this bottom one. Okay, again, vertex is a point where three or more edges come together to meet. So we have one here, 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 and one here. Again, 4 at our base and 4 at our top for a total of 8 vertices. Okay, we have our next solid here. We're going to start by looking at the shape of the base of this solid, because that will help us name the solid figure. Okay, now I know that looks a little bit rectangular, but I think that is actually a square. Okay, then also I noticed that all of the faces other than the base are triangular, and they come together to meet at one vertex. That means that if this were a square prism, well, we'd call that a cube, or a rectangular prism, that there would also be an opposite rectangular face that would be the same as the base up here, and there is not. So that helps us name this as a pyramid. This solid is a square pyramid. Okay. Okay. Now we're going to do after that, we're going to count the number of faces. I know that my base shape is a square, so I will count that as 1. One of the things that you will start to get used to doing as we go through this unit is thinking about, hey, like, what do I know about squares? Well, I know that a square has 4 sides, or rectangle has 4 sides. That means that there are going to be 4 triangles, one that comes off of each side of this. So if I think about that, I have one figure or shape as my base, 1, and then plus 4 triangles, 1, 2, 3, and then this one right in front is a little bit tricky to see or name, but 4. So 4 plus 1 is 5. That is how many faces we have in our square pyramid. Okay, let's go ahead and work on our edges now. Remember, edges are where 2 faces meet, or 2 of those flat surfaces on our solid. Okay, so I'm going to count 1, 2, 3, 4. That is for my base shape meeting the triangles. Okay, and then because again, I know I have 4 triangles that come off of there, I'm going to have 1, 2, 3, 4 more edges. Again, 4 plus 4 is 8. That is how many edges this figure has. Okay, I'm going to erase that. And then lastly, we're going to count our vertices. Remember, vertices are where 3 or more edges meet. So for example, there's an edge, there is an edge, and there is an edge. 3 of them come together. We count that as one vertex. 1, 2, 3, 4. And that should make sense because our base we know is a 4-sided polygon. So we have 4 on our base. And then each one of these triangular faces, all of the edges formed by those faces come together and meet at one vertex at the top. So we have a total of 5 vertices in our square pyramid. Okay, we're going to do the same thing with this next solid you see on the screen. Again, our learning target is to identify bases, faces, edges, and vertices of three-dimensional solids. I'm just going to start with the shape of the base of this figure because that helps us name or identify the solid. Remember, the base, when we're talking about prisms, is going to be the face that is not rectangular, or if all of the faces are rectangular, we still have a rectangular prism and our base will be a rectangle. If it is a cube, then all of the faces will be square. Now you should be able to see that two of these polygons that make up our faces really are different or stand out from the others, and that is going to be our top or our bottom. Because they are exactly the same, we could use either one of them to talk about the base. I'm going to use this one on the top actually to talk about the base because I see that they're identical. So if I find out how many sides to name this polygon, it is the same as the base shape. Okay, 1, 2, 3, 4, 5. And remember from yesterday that a five-sided polygon is a pentagon. Okay. I also see that the other sides that are not pentagons, or the top or the base, are rectangles, so that I know the name of this is a pentagonal prism. Okay, the next thing that we're going to work on is counting the number of faces that this figure has, the solid has. Okay, we already talked about our top and our bottom, or our top and our base. I'm going to count our top as 1, and I'm going to count our bottom as 1 for a total of 2. And then one thing again you should start to do as you're getting experience with these solids is if you know that a pentagon has 5 sides, then that means that there are 5 rectangles that come off of that face, that pentagonal face. Okay, so I know that there are 1, 2, 3, 1 in the back, 4, and 5 rectangular faces. So I have 5 here, kind of in the middle, and then 1 on top, and 1 is our base. 5 plus 2 for a total of 7 faces. Okay, next, let's work on our edges. Remember, we're going to find the number of edges. And again, when you get practice doing this, you're going to start recognizing some common things and thinking about what you already know about those flat faces. That's going to help you do this a little bit more efficiently. So instead of starting to count 1, 2, 3, 4, 5, I know there's 5 on the top and 5 in the middle and 5 on the bottom as far as edges go. We're going to do that today. I'm going to model that. But for some of you, this is going to start to become a lot more natural. So I'm going to again count edges. That is where 2 faces meet. Okay, so I have 1 here, 1 here, 1 here, 1 here, and 1 here for a total of 5. Now that should make sense because again, we know we have a pentagon, which means 5-sided, and that is where those 5 sides of the pentagon are meeting up with the other rectangular faces that make up our prism. Okay, I know that I have 1, 2, this one's a little tricky to see back here, 3, 4, 5, kind of in our middle there, or where the rectangular faces that come off each side of that pentagon are meeting. And then lastly, if we count our edges on our base, where the sides of our pentagonal base or a pentagon base are going to meet with those rectangles, we should have 1, 2, 3, 4, 5 again. And that should still make sense, kind of us checking our work here. We know a pentagon is a 5-sided polygon that makes up our base. So 5 plus 5 plus 5, or you could also look at this as 5 times 3 for a total of 15 edges. Take some time to erase that. And then lastly, I'm going to use our red marker again. We're going to count the number of vertices in our figure. Remember, vertices are where 3 or more edges meet. So I'm going to illustrate one of those real quick. Here is an edge, here is an edge, and here is an edge. Where they meet, that point that is made is a vertice or a vertex. we're talking about one, it's a vertex. We're talking about more than one, they're vertices. And I know there's more than one in this figure. Okay, so we have one here. I'm going to do the base vertices first. 1, 2, 3, 4, 5. Again, we should be making some connections here. We know that a pentagon is a 5-sided figure. So on that base, it is going to meet up with 5 rectangles that form the solid. So each one of those points there is a vertex. So we have a 5, and there is not going to be any kind of in the middle because we only have 2 rectangular faces meeting here and here. This is not a vertex, that is an edge. So do not count that as a vertex. Remember, we want 1, 2, 3 edges to be meeting to make a vertex. 2, 3, 4, 5. So we have 5 on our base and 5 on our top for a total of 10 vertices. Okay, this is going to be the last solid that we practice our learning target on today. Remember, our learning target is identifying shape of the base, the number of edges, faces, and vertices in a 3-dimensional solid. Okay, so we're going to start with the shape of our base. And the shape of our base is going to be a little bit easier to see on this solid because it is transparent, or easier to count. I'm going to start by counting 1, 2, 3, 4, 5, 6, 7, and 8. So we know that our polygon that is the bottom of our figure is an 8-sided shape, which we know is an octagon. Okay, I'm going to put that up here. This is going to be an octagonal. And then what we're going to try and answer is this going to be an octagonal prism or an octagonal pyramid? Now, if this were a prism, one thing we know about prisms is that they have a shape on the top that is exactly the same as the base. And I'm hoping what you're seeing when you're looking at this solid is that we have an octagon as our base, but there is not an octagon at the top being connected by rectangles. So right away I see there are triangular faces that come and meet at one vertex up there. So that means that this is an octagonal pyramid. Okay. Okay, after we have done that, let's go ahead and next count the number of faces that we see in this solid. Again, we just named this solid an octagonal pyramid. That means that we have octagon as our base. Let's count that as 1. And then again, starting to think about what you know about octagons. An octagon has 8 sides, meaning that there are 8 triangles that come off of this base. So if I were to count them, and I could do that, it's going to get a little bit messy when we do this, but there are 1, 2, 3, 4, and then there should be 4 in the back, 2 that we can't really see, triangles that come off of that base. So if we have 8 triangular faces that meet at that vertex, and we have 1 face, octagonal face is our base, 8 plus 1 should give us 9 total faces in our solid. Okay, next we're going to work on finding the number of edges. Okay, I'm going to use blue for that. Now, again, think about what you know about octagons. Octagons have 8 sides. They are an 8-sided polygon. It's an 8-sided polygon. So that means that here and here and here and here and here and here, each one of those 8 sides of our bottom face or our base is going to make an edge, meaning where the octagon face meets the triangle face. So I know that there are 8 here. Remember, edges are where faces meet to form those lines. And then if we have 8 triangles coming up, and we could count each one of these, 1, 2, 3, 4, and then each one of these dotted lines is 1, 2, 5, 6, 7, and I missed this solid line right here for a total of 8. So 8 where our triangular faces meet each other, and 8 where the octagon meets the triangular faces. So 8 plus 8 gives us our total number of edges is 16. Oops, made a little mistake right there. Let's just do that again. 16. Okay, lastly, we're going to count the number of vertices. I'm going to start with our base shape here, which I know is a octagon, meaning that we have 1, 2, 3, 4, 5, 6, 7, and 8 vertices, meaning where 3 or more edges meet. 1, 2, 3. So each one of those that I just circled, all 8 of them are vertices. Okay. Lastly, all of our triangular faces come together and they meet at one point, which is up here. This is one vertex. So we are going to add 1 formed up there by the triangular faces meeting to 8. 1 plus 8 is going to give us our total number of vertices, which is 9.